There are a number of different ways to remove structures in Table. The simplest way to do this is to tap on the Explorer icon and select the Removal tool. With this tool active, any structure that you tap on will be removed, and it will be annotated as it's removed. Clicking Undo will bring structures back in the order that they were removed. The Clipping tool can be used to make a cut in a flat plane. When you open the Clipping tool, you will see the Custom Clip and 3 standard clips that can be applied. The Sagittal Clip allows you to cut and scroll through a sagittal plane. You can scroll through planes using the slider bar at the bottom of the screen, or using 3 fingers on the table will allow you to scroll more slowly through the planes. You can undo your clip by tapping on the Reset icon in the Clipping menu. As with the Sagittal Clip, the coronal and axial clips will allow you to scroll through their respective planes using either the slider bar or 3 fingers. Within the Clipping menu, you'll also find the Reversal icon, which will allow you to reverse the clip if you prefer to scroll through your specimen from the opposite direction. The Custom Clip, which is selected by default when you open the Clipping tool, allows you to make a clip at any location by drawing a line and tapping the side that you want to remove. With the Custom Clip, you can make up to 6 cuts, which can be useful for quickly isolating a particular structure or region, or just creating a very unique view of that region. It's important to remember that when you make multiple cuts, the scroll bar will only slide through the plane of the last cut that you made. If you want to leave certain structures intact when you make a cut, you can apply no clip to that structure by using the Volume Visibility menu and clicking on the black circle next to that structure's name. You can apply no clip to as many structures as you would like to remain uncut, and once you apply the cut, those structures will remain intact when the surrounding structures are removed. This can enable you to remove external structures while leaving internal structures intact. Another way to cut structures is to use the Dissection tool. When you tap the Dissection tool icon, the Curved Dissection tool is selected by default. The Curved Dissection tool allows you to select a specific region that you want to dissect. By drawing a circle and tapping on the inside of the circle, you'll be able to dissect all structures or parts of structures located within that designated region. This tool simulates dissection by enabling you to tap on structures and remove them one by one from superficial to deep. Note that it also annotates each structure as it removes it. To undo a cut, tap the Undo button, and structures will be returned in the order that they were removed. As you can see here, only the parts of structures within the designated region are cut during this process. The Linear Dissection tool allows you to remove structures or parts of structures that are on either side of a designated line. I can use this tool in conjunction with the Curved Dissection tool to dissect parts of structures that are in my previously designated dissection space. You can also dissect individual structures using the Action menu. If you tap on the structure you wish to dissect and open the Action menu, you can do either a curved or linear dissection. Again, you want to select the area that you want to remove, tap on the inside of the circle, and it will remove just that portion of that structure. The final cutting tool is the Freehand Sculpt tool. This tool will remove all structures within a designated area unless they are turned off in the Volume Visibility menu or designated as no clip. As with the Dissection tool, select the area that you want to remove and tap within the circle. The Freehand Sculpt tool can allow you to create some truly unique views of structures and regions, like the ones you might see in textbooks or anatomical models in the classroom. This can help students create a link between 2D pictures and 3D anatomy.